Step 2 of proving this theorem is that we know that vector v and vector w are unit vectors, and vector v is cosine alpha I plus sine alpha j. I is associated with the x side and j is associated with the y on the Cartesian plane. And we have a range for alpha from 0 to pi. We don't want to mess around with anything past the second quadrant. And the same thing goes for vector w, where we have cosine beta right here plus sine beta j with the same range. Now, our next step is to use Theorem 8. Theorem 8 states that cosine theta equals vector w times vector v, got that backwards, all over magnitude v multiplied with magnitude w. Since these are unit vectors, their magnitude is 1. As a result of that, magnitude w equals 1, and magnitude v is 1, and magnitude w is 1. So we have cosine theta equals vw over 1. And we know what v is. Cosine alpha I plus sine alpha j. That's v multiplied with cosine beta I plus sine beta j. That's our w. That equals, and we just use a simple FOIL, and we end up with cosine alpha cosine beta plus sine alpha sine beta. We drop the I and the j at this point. Now, going back up here, we see that theta is equal to alpha minus beta. Okay? Theta is equal to alpha minus beta.